Well, here we are. We've reached the final section of working on switches in our LAN environment. Feels like we just got started and we're already to the point where we're going to talk about optimizing and troubleshooting our switches. What we're going to do is just paint a 10,000-foot view, a broad overview of when problems happen in the network, what to do. We're going to start off by looking at the most common problem in switch networks, and that is the speed and duplex. We'll then identify the place of the spanning tree protocol. Now, this series does not get into spanning tree in depth. That's the part of the next series that prepares you for the CCNA exam. In here, I just want you to understand what spanning tree does. The last piece we'll look at is using show commands to troubleshoot networks and sitting on our switched environments when somebody's complaining of a problem, where to even begin with our show commands. Well, let's start off with the number one most common problem that you'll probably run into in the switched environment. That is the speed and duplex. By default, every single port on a Cisco switch has the speed set to auto and the duplex set to auto. What that means is these ports will auto detect everything that plugs in. So you plug in a PC or a router or a server, and it will attempt to try and auto detect what speed the network card's running at, 10 or 100 or 1000 megabits per second, and what duplex, half or full. Now the problem is the auto detect mechanisms are, well, they're old. They're designed for network cards of yesteryear, and the network cards have evolved over the years. I mean, we've introduced features that they never even dreamed of. So a lot of times, well, some of the time, the auto detect mechanism will detect it incorrectly on a switch port. And will say, well, I think that the duplex is half, and really the other side auto detects it as full. And you end up with a duplex mismatch. Now, I will tell you that all of the time, the switch will be able to detect the speed correctly. It's the duplex that causes the problem. Either one side will detect full and the other half, or vice versa. And what ends up happening is you get these errors that are displayed on your switch. Let me see if I've got some. There we go. This is actually a duplex mismatch that was discovered, leaving everything at auto. I didn't do anything to cause this error. I plugged in a router into one of the switch ports, and the switch immediately said, oh, a duplex mismatch is discovered because both sides are set to auto. Now, the irony of this whole thing, and it makes me scratch my head every single time, is you think, okay, they're set to auto, so they should auto detect when something is mismatched, right? And they do. Do you see the irony? If it can detect a mismatch, then why doesn't it fix it? Well, the answer to that is because the switch doesn't really know whether you want it to be half or full, so it just says, hey, there's a mismatch. Please tell me what to do. Now, the problem, and the reason that this is such a big issue, is the only time that you see these messages is if you're plugged into the console port of your switch, or if you telnet in and actually turn on the monitor to where you type in terminal monitor, which will display all the messages. So you won't normally see these messages unless you're plugged in. The symptom then is that the person who is connected to that switch port will be complaining. They'll just start issuing trouble tickets, and they'll say, hey, my network connection seems slow. Now, to you as the network administrator, you're, up a creek without a paddle on that kind of report. What do you mean it seems slow? Is the internet slow? Well, yeah. Is your email slow? Well, that's kind of slow too. Is the server slow? Well, yeah, I guess that's kind of slow too. I mean, what does that mean? It's just everything's running slow. Does that mean their computers bogged down? Are they using an older PC? The last thing you'll tend to look for is these duplex mismatch. The reason it's slow is if one side thinks it's half duplex and the other side thinks it's full, well, this side thinks you can send and receive at the same time. So it'll be sending some and trying to receive some all at the same time. This side thinks you can only do one or the other, so it will end up having collisions. Collisions on a switch port. It should never happen. But data will end up getting dropped and having to be retransmitted. So the slow symptom is just the data getting dropped. So what you need to do, and one of the most common issues is, you need to go into the switch, and I'll move into global configuration mode. And the first thing is understanding this error message. It says duplex mismatch discovered on fast Ethernet 0/2. That is telling you the local switch port on your switch. It's saying fast Ethernet has the problem. So I'll go under interface fast Ethernet 0/2, and it says it is not half duplex. And it says with access server Ethernet 0 half duplex, meaning it's detected the other side, the router named access server that's plugged into here, is set to half duplex. So I need to go under this interface and I'll say duplex half in this case to match the other side. And if we hard code the duplex, you see it'll shut down the port temporarily while it does that, but you'll also want to hard code the speed. So I'll say speed is 10 megabits per second, which is what the other side is set to. That is hard coding the speed and duplex. It does cause the interface to bounce down and go back up, so it will cause a disruption in network service. Now, in the real world, I will tell you the auto detection rates that I'm estimating just from my experience are probably between 90 and 95% success. Meaning, if you leave them on auto, about 90 to 95% of your devices will be successfully detected. Seems like a pretty good percentage. But if you think about it, 90%, that means 1 in every 10 machines will have an issue. So what most people will tend to do is allow the PCs to be auto-detected. Because, hey, if they get slow access, no worries. But the servers, main connections on your switches, servers and things like routers or printers, major printers that everybody is connecting to. That's my printer right there. And, other major connections, things that go between switches, like uplinks to other switches with crossover cables. Those are all hard-coded with speed and duplex, so you're assured that both sides gets the right connection type. That is the world of speed and duplex. Now, I just thought of this, so forgive me. I'm going to add a bonus section to this chapter. As we were working in here, we kept getting these messages, and they were kind of flying through and interrupting what we were typing. Have you noticed that? If you've worked on a Cisco device, these messages kind of get annoying. I mean, they're useful. You want to see them because they tell you when things happen, but they're bothersome. So we are in the section on optimizing switches. So I want to show you how to optimize these things when you're working with them. I want to show you a few shortcuts that I've learned over the years that have become very handy for me. Now, if you're studying for the certification exam, chances are these things aren't going to be on there. But man, if you're working with these things, they're great. So the first thing is these messages, right? They're useful and you probably want them, but let me show you something. If you're working, I'm going to type in show IP. You see what happened right there? These messages kind of split up what you're typing. I was typing here and it now puts it at the end and I'm typing. Now, of course, if I keep typing, it will fix itself and the command will work, but it's just kind of annoying. So what I want to show you is a command that fixes that. I don't know why it's in there by default, but I go under my console port, I'll say line console 0, and type in on every device I'm configuring, logging synchronous, enter. I also go under the telnet ports. I'll do line VTY 0 space 4 and type in logging synchronous. So no matter, whoops, great. I'll show you how to fix that too. No matter where I'm at, this logging synchronous command will take effect, meaning that no matter how I'm connected to this device, there we go, this command will take effect. Now, what does the command do? Well, let me show you. I'll do the same thing. I'm going to exit back out and start typing a show command. I'll type in show IP interface brief. You see what happened? Sure, the status message still came. However, it repainted automatically what I was typing below. So I didn't end up typing at the end of this message over there. So it saved, you still get the messages, which is good, but it saves a lot of pain of interrupting what you're typing and you can finish your command. So that's the first tip. Second tip is when you're working with devices, by default, it will kick you off if you don't do something for 5 minutes. It's the idle timer, meaning if you haven't done some command or type something for 5 minutes, you will be automatically disconnected. That's a pretty short time. Now that's good for security, so if you leave your desk and you leave a connection up, somebody can't jump in there and start configuring your device. But for most people that's pretty short. So again, I'll go under both ports, line console 0, the console port first of all, and I'll type in exec timeout followed by, and you can type in the number of minutes. I usually say 30 minutes and 0 seconds is a good time, because if you aren't typing something for 30 minutes, it's about about time to get kicked off. You can disable that. If you want to stay on unlimitedly and never get kicked off, you can type in no exec timeout, and that will never get you kicked off. But that's a dangerous command to type in because, well, I mean, that if you leave your console and forget about it, that means anybody can walk up any time of day or night and get in there. I'm going to go under line VTY04 and do the same command. Exec timeout 30 minutes, which means when I'm telnetted in, it will also give me a 30-minute idle timer. Cool. So that's tip number 2. Now, tip number 3. As we're working with these switches, a lot of times you may get into working pretty fast and mistype something. You notice it happened to me up here. I'll show you again what that is. So let's say instead of show, I type in flow or something like that and hit enter. Immediately, what the switch will do is take you into this translating flow to domain server prompt right there, which is, it's kind of annoying. Sometimes it'll wait, 30, 60 seconds before you actually get your prompt back. What it's doing is it's trying to resolve that name to an IP address, meaning it thinks you're trying to access some device named flow. And it's going to send broadcast. This is a broadcast IP address. It's sending broadcast saying, hello, does anyone out there know who Flow is? Flow, I'm looking for Flow. And it's waiting for somebody to respond and say, oh, I'm Flow, and here's my IP address. So that is known as a domain lookup. It's trying to look up that IP address. So we can type in no IP domain lookup, and that turns off that feature. So now if I type in Flow accidentally, you can see it just says, oh, nope, sorry, unknown command or unable to find computer address, because I'm no longer going to send those broadcasts. Excellent. That's tip number 3. And I think, oh, no, one more tip. You'll get into a point where you'll start using these show commands all the time. For example, I always use show IP interface brief because it gives me a quick view, you can see there's my command, of all the interfaces on my device and what their status is. So show IP interface brief is kind of annoying to type because it's a little bit longer. So what I do is I go into global config mode and I create aliases for all the commands, primarily that one that I type all the time. You can type in alias and then what mode you want the alias for. This mode is known as privilege mode, or a lot of people call it the exec. So it's actually alias exec, then what you want your alias to be. I like to make S my alias. So I say S really means show IP interface brief. Enter. Now when I want to type that command, I just hit S. Tip of the day, huh? So that'll allow you to create these shortcuts that you can use all over the place. You can make shortcuts for saving your config, like I could say maybe say, or whoops, alias exec. Save is copy running config startup config. And now I can just type in save, and poof, it says, what do you want to save it as? Startup config. So some shortcuts. That's my optimizing, the bonus section on how to just start working with these devices a little faster. Those commands work on switches just as well as they do on routers. All right, now let's talk a little bit about this concept known as spanning tree protocol. I think I may have mentioned this before. I'm forgetting now, but if I have, just listen one more time. It's good stuff. If you're ever looking for some Friday night fun, meaning you're bored, here's what you do. You take a PC, plug it into a switch, take a PC and plug it into another switch. Now these are just no-name generic switches. Don't spend too much money on this Friday night event. And then connect a crossover cable like this. Then turn off all the lights, kick on your favorite music, and connect a second crossover cable like that. Within a few seconds, the switch lights will start blinking like mad because you've caused a loop in the network. Meaning, when this computer sends a broadcast, a switch will send it out all switch ports, which means it goes out right here and right here. This computer gets it on its crossover cable on both of those and says, well, I need to send that broadcast out all switch ports, so it'll send it out here. This one loops around and goes right here. This one loops around and goes right here. And the system happens again. This comes out here, loops around here, and you can see this loop, 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 all around unlimitedly. Your PCs end up dying, meaning they freeze because they've got so many broadcasts hitting them every single second that they can't keep up with it. So this is known as a broadcast storm. Switches will forward all broadcast packets out all ports by design. So the solution to this is not to stop the broadcast. At the same time, redundant connections are necessary in businesses. Now, I said let's do this for a little Friday night fun, connect some crossover cables like this. But in businesses, redundant connections, meaning double cables, are good. So that way, if one of these ports go bad, which does happen, maybe that one goes down, the switch can say, oh, well, I've got a backup, so I can still reach between these devices. So the place of the spanning tree protocol is to drop trees on redundant links until they are needed. Now, that's kind of metaphorical, meaning you don't literally see trees falling in the network, but it is kind of a good analogy to remember what the tree does. The switch will say, here is your tree. Looks kind of like a piece of broccoli. Just fell over on the redundant link. And that link will be blocked, meaning that there will be no broadcast storms in the network unless this link goes down. So the spanning tree protocol will watch your active link at all times to make sure that it's still forwarding, going between these two switches. And if it ever stops, then it will say, oh, time to raise that tree back off of the line and allow this one to go active because this link just died. That's what spanning tree does. Now you might say, well, that's simple enough. Why do they need a whole protocol just to do that? Well, there's a lot more to spanning tree. And that's where I was saying at the very beginning, I said this will give you a 10,000-foot view of spanning tree, but really there's a lot more to it. Because this is a modern network design. Meaning this is what it looks like in larger businesses. You've got all kinds of devices plugged into these switch ports over here, PCs and servers and so on. And they have connections up to a upper layer switch. Some people call that a distribution layer, meaning that is where it's kind of like a choke point where all the switches kind of come together into one consolidated switch. This connects down here to, this is what a lot of people call the core of the network, or the backbone, where everything kind of comes into one major area. Now look at this diagram. Do you see any redundant links in this picture? Yeah, everywhere. I mean, if you look, and the redundancy is good, all of these switches have redundant links to their distribution layer. So if one major switch fails or one link goes bad, they always have a backup link that they can use. This has got redundant links like that. The distribution layer have redundant links going to the core. So if one core switch ever goes down, they can always use the second one as a backup. Redundancy is everywhere, and that's good. But now you come to the question of, wow, what links get blocked? I mean, spanning tree protocol has to figure out how to disable, essentially looking at this picture, 50% of these links must be blocked in order to stop those broadcast storms from happening. So we come to the question of which ones? That is the rest of the story, as Paul Harvey would say. That's the rest of spanning tree, and that's what they talk about in IC&D Part 2, or that's what I talk about in IC&D Part 2, which is the second half that allows you to get your CCNA. Just for now, what I want you to see is what spanning tree does. Spanning tree blocks redundancies until it's needed so you don't have loops. How it does that is another story. All right, the last thing I want to talk about is troubleshooting. Where do you start when things are going wrong? I've got 3 show commands that you can use on Cisco switches to really get a good scope of what's happening. Meaning you get a call and they're saying, hey, my computer doesn't seem to be working. It's showing XYZ, or things are running slow, or, any report comes in. Where do you begin on the switch? I usually start with this command right here. It's my favorite, show IP interface brief. It's the one we just made the alias for, where I typed in S to get that, but I'll type the whole thing just in case. Show IP interface brief will give you a report of all of the interfaces on your switch and their current status. So if somebody is calling and saying, hey, my port is not operational, let me show you this. If I was under interface fast Ethernet 0/4 and shut it down, which is a common practice because you usually shut down ports that aren't in use for security purposes. If somebody's calling and complaining saying, hey, my switch isn't working or my computer's not working, I look and I go, oh, well, I'm seeing you're connected to a port that's administratively down, meaning Somebody has typed shutdown under that. So I need to go underneath that port and type in no shutdown to get it working. And that brings it up if there was the device actually connected. Likewise, you're able to see the status, meaning physical layer, and protocol, meaning data link layer of each and every interface. If one of these is up, like the physical, and the other is down, that typically means there's some kind of communication error. Like maybe you've got some bad cable going between those two devices. Or maybe you've got, well, it's getting into some advanced topics, but you've changed the encapsulation, kind of the language that the switch is speaking on that. So this output really gives you a lot. Now, let's say, everything's looking good. They're complaining that it's slow, and you found out they're connected to fast Ethernet 0/2. Both of them are up. That's where we can move on to that second show command and type in show interface fast Ethernet 0/2. Enter. When you do that, you're going to see a lot of information. First off is what we saw in the show IP interface brief. I see that it is up, physical layer, and the line protocol is up, data link layer. I see the MAC address that's assigned to the port, and that's the built-in address, BIA, of the switch. This isn't the MAC address that it learned on that port. That's in the MAC address table, show MAC address table. I can see, some information we're not going to cover, like the maximum transmission unit, the bandwidth, the delay that's used for routing. We'll talk about that later. You'll see the reliability, which means how reliable is this interface. 255 out of 255 means it's 100% reliable. As you start having errors, meaning the interface gets disconnected and reconnected and disconnected and reconnected and this reliability will go down. Instead of using a scale of 0 to 100%, Cisco decided to make it 1 through 255, where 1 is pretty much 0 and 255 is pretty much 100%. Why they did it that way? Because. You see right here we have TX load and RX load. TX load is how much load is currently on the interface, meaning how much are you sending, TX is sending as of right now. 1 out of 255 means it's essentially not in use. There's not much traffic going over this. This is how much are you receiving. Now, I never remember TX is sending. It technically stands for transmit. How much load is being transmitted right now? But I always remember R means receiving. So right now the receiving is very little. It's receiving almost no traffic on this interface, and the sending is very little. That's how you can tell if an interface is really bogged down, like somebody's sending a lot of data. Now drop down with me. I can see that this interface is set to half duplex. It's also set to 10 megabits per second, but it's connected to a 10/100 base T interface. So we can support more bandwidth if the other side can support it. Drop down a little bit more, and you see the 5-minute input and output rate from the switch's perspective. How many bits per second is it receiving and sending? You'll see how many packets. Matter of fact, I'm going to hit the arrow. I think fast Ethernet 01. Yeah, this one has a little bit more action going on. I can see the 5-minute input rate over the last 5 minutes. I've sent 1,000 bits per second, or 1 packet per second. Not that much at all, but at least it's better than nothing. I can see how much is being output. And this is the historical perspective, meaning how many total packets have been input, how many bytes have been input. Now, right underneath that, you can see some more valuable data. How many broadcasts have you received? If you have a lot of broadcasts, meaning you're looking at the total number of packets and you look at the total number of broadcasts, well, let's figure that out. I'll open the Windows calculator and say 14446 divided by 17,928. Enter. As of right now, 80% of my packets are broadcast, 0.80. Wow. I'll tell you that an average network, well, I should say this, a high level of broadcast is considered to be 20%. Now, my network is insanely overpopulated with broadcasts. And the reason why is this is just sitting in a lab environment. I don't have any real network traffic actually using that port. So what it is just a computer every now and then saying, hey, is anybody out there? Hey, is anybody out there? Sending these broadcasts. So that's why my statistics are very skewed. Let me telnet to a production switch that I have. I'm actually using in a production office. I'm going to type in telnet, show you Let me do a show interface description. Again, we haven't gotten this far yet. Just want to find what interface would be in use quite a bit. Let's do Fast Ethernet 04, the wireless link. Show interface Fast Ethernet 0/4. I hit enter. There we go. That's a little better ratio. Lots of packets input, and it looks like a lot of broadcast, but you can see percentage-wise, there's still a lot more packets than there are actual broadcasts, whereas the percentages are skewed on my lab equipment over here. Now, underneath that, you see runts, giants, and throttles. Input errors, CRC, frames, overruns, ignores, all of those. Those are bad things, meaning a runt is a packet that is just too small, meaning it doesn't have enough information in there to be considered a real packet. Giants are packets that are too big, meaning there's too much information. It's bigger than a packet should be. Those kind of packets get dropped. Now, they'll typically result from a bad connection, meaning you have a connection that maybe goes by some fluorescent lights in the ceiling or runs through a wall by a microwave, or there's some kind of interference that's really goofing up your connection, or you just have a bad cable and the packets are not passing the CRC check. Remember, at the very end of every layer 2 packet in the frame, there's that FCS or CRC. It's just a little mathematical formula that checks if the packet is good. If you're seeing these things increment up in a big way, these guys right here, that's a good sign that there's some kind of interference. I would start tracing the cable, run through the ceiling, see where that cable is going. If all else fails and it's not going by anything that seems to cause interference, you might just run a separate cable and test it and see if it's the cable that's the problem. Otherwise, it could be the network card in the PC that's causing problems, or it could be the interface on the switch is starting to go bad. Now down here, I'm going to skip this one. It's too much right now. Watchdog, multicast. We'll talk about those in one of the more advanced course. Down here, you can see the packets output and the bytes output, what's being sent. Output errors, collision, late collision. These are the two that I want to talk about. Collisions and late collisions. A late collision typically happens if your cable is too long, meaning you've actually started going beyond the 100-meter maximum of the Ethernet cable, or you've got maybe a device in the middle and then another 100 meters and then another switch and then another 100 meters, meaning the actual distance from one end or one PC to whatever it's trying to reach over here has become too long. What happens then is the packet gets sent and it's going. It takes too long to arrive, so this guy resends the packet thinking it got dropped along the way, and meanwhile this one sends an acknowledgement saying, oh, I got the first one, and all of a sudden a second one comes in. That is considered a late collision. So if you see late collisions ticking up, that means you've got too much cable or too many switches in between these two devices. Collisions themselves will typically happen if you are they can happen if the cable's too long, but also if you have a duplex mismatch and things are being sent and colliding because one side thinks you can only send or receive, the other side thinks you can send and receive. So a lot of good info can be seen from these show interface commands. However, this is usually when you're looking at this, that's when you're into the nitty-gritty troubleshooting, meaning you've checked all the obvious things. Now you're looking at the actual packets of what's going on. Last but not least is the show run command. Show run, we just saw a show interface. Show run will show you what the actual configuration of the switch is. You've seen this a couple times. The full command is show running config. I hit enter and you can see every command that's been ever typed into the switch. You can even see, if I scroll back up, the MAC address sticky that we did from one of the previous videos to implement port security. All of the commands that we've typed in here, the IP address. Now, this is a quick way to verify your configuration, and a lot of times if something's wrong, it may be because of something that you typed in. So show run will tell you what's typed in. Now I have to warn you, because I've taken the IC&D1 or CCENT exam from Cisco. In the simulations, show run a lot of times is the easiest way to figure out the problem. For example, they might have a simulation where they tweaked the duplex to be wrong on one of the sides, and you could just type in show run and see, oh, well, they've typed in duplex half. No brainer. But Cisco's kind of cruel, meaning that when you're in the test simulation, a lot of commands will work and they'll also restrict access to some of the commands. Meaning they may put some configuration in here that's wrong and you know that it's probably in there and you want to use a show run command, but when you type in show run in the simulation on the test, it will actually come up and say, sorry, that command's not supported. They didn't make a mistake. It's not like, oh, we forgot to design that into the simulation. They did that on purpose because they know show run is an easy way to find a lot of problems. But they also want you to know many of the other show commands that exist, like show interface, which will also show you what the duplex is. Let me just hit the up arrow real quick. You can see it right there, but you need to know what you're looking for. So that's why it's good not only for the real world, but also when you're studying for certification to know multiple ways to get to the same objective. All right, that is the world of switches. Let's wrap up and hit the high points. The first thing that we did was talk about a very common problem that happens in the switch environments. That is duplex mismatch. So a lot of times on key ports, it'll pay off to hard code both the speed and the duplex on both ends of the connection. We second saw the place of the spanning tree protocol. Its goal? Drop the trees on the redundant links. Make sure that you don't have broadcasts that keep looping around the networks. That's its purpose. There's a lot more to it, but for now, that's all you need to know. Finally, we saw the show commands to troubleshoot networks. Show interfaces being a big one, but also we can use the show IP interface brief to see a quick status and show run to see what configuration we've typed in. I hope this has been informative for you, and I'd like to thank you for viewing.